Hi, welcome to the channel. My name is Wallace. In this video we are looking at engineering science and we are covering the topic forces. In this video we'll be doing an introduction to forces. As we know, forces are found in N2 and in N3. In N2 they call it falls under statics. In N3 it is a topic on its own called forces. In this video I'll try and cover both the N2 and N3. It will just be basically an introduction which will cover both N2 and N3. Alright, so with forces, first thing that we need to know is what is a force. A force is an influence that tends to change the state of motion of an object, or a force is what brings about acceleration or what changes the momentum of an object. So a force, when applied on an object, it wants to change the state of motion of an object. So a force is a pull or push, basically, as most people like to say. So under forces, we need to know the units for the force. Unit for force is newtons. We'll be using the letter N for forces. It can be kilonewtons, meganewtons, and so on, but the unit is newtons. And then the other thing that we need to know is that a force is a vector. A force is a vector quantity. It has got magnitude. Magnitude basically is the size, and it has also got direction. So a force is a vector quantity. Vector quantity is any physical quantity that has got magnitude and direction. So a force or forces have got magnitude and they've got direction. Magnitude, basically the size, how big the force is, and direction, in which direction it is going to. Either it's going to the right or to the left, or going up or going down. Or you can also use the compass directions. You can say east, west, north or south in terms of direction, but a force should always have a direction to it. So for example, if we say we are applying a force on this object of 18 newtons. 18 newtons is the magnitude of the force being applied on this object, but then in which direction are we applying? So if we include an arrow to this force, 18 newtons, our arrow shows us that 18 newtons is being applied to the right direction. Alright, so a force should always have magnitude and direction. Then in the same manner, we might have several forces acting on this object. Let's say if we have two forces, the other force is acting in that direction. I'll give this force 10 newtons. Okay, so we have two forces acting on this object. One force, 18 newtons, is pushing to the right, 10 newtons is pushing to the left. So the resultant, or the net force of these will be a total of these two forces. We add up 18, we add and 10, we find the resultant. So the net is also what you'll be calling the resultant, basically just the net force. Now, when it comes to adding of vectors, we can't just say the sum of these two forces is 18 and we say plus 10. That would be very wrong. This will give us 28, but which would be very wrong. We have to consider in which direction are they working. So when it comes to the direction, we'll take going to the right, we'll give it a positive value. Going to the left, to take up a negative value. Going up, to take up a positive value. Going down, we'll give it a negative value. So these directions, or these symbols, the negatives and the positive, are just for us to help us resolve these two forces. So we say positive 18 going to the right, negative 10 going. If we now add up 18 plus negative 10 gives us a positive 8 newtons. So this positive 8 newtons just simply tells us that that's the direction. So we can say it is 8 newtons. The resultant of these forces is 8 newtons to the right. What this basically means is that these two forces is the same as if we only have one force acting on this object, one force of 8 newtons acting on this object. So these two forces, 18 and 10, the resultant is just 8 newtons acting to the right. So that is the resultant. and we'll be required to define what a resultant of a force is. So that is one definition that you might need to know. Resultant of forces. Resultant of forces is the sum or the vector sum of all the forces acting on an object. So that is what resultant of a force is. The vector sum, we add up 18, we add 10. So we have to consider also the direction. Alright, then the other thing that we need to take note of is that it is not always that the resultant of the force will be a positive number. Sometimes it can be a negative number, where we have, maybe if we had maybe 70 newtons this side, we have 100 newtons on the other side. If we find the resultant of this, the net force of this, will get ourselves 70, positive 70 plus negative 100, will get negative 30 newtons. This negative, according to our direction, this means it's 30 newtons to the left. That negative sign goes out. The negative sign is just for our direction. So that is how you'll be dealing with the direction. So sometimes our net force, let's say for example we have 100 newtons on this side and 100 newtons on that side. The net force will be 100 newtons plus negative 100. Our total force will be 0 newtons. This object is the same as if there is no force acting on it. This object is said to be in a state of equilibrium. This object is in a state of equilibrium. The other object that we saw where we had 18 and 10, that object was not in equilibrium, it was not balanced, but this force is balanced. Equilibrium simply means balance. So equilibrium is a state or a condition where the net force, after we calculate all the net force, our resultant force. So equilibrium is a state when the net force is equals to 0. So it is a condition or a state of balance. Equilibrium is a condition when the resultant of forces is equals to 0. That is what we will call equilibrium. So let's say for example they will say, I will go back to my 18 and my 18 newtons. We have our 10 newtons. I'm just using these numbers for easy calculations. We have 18 newtons, we have 10 newtons. Like we said, this force is the resultant. Okay, so this force, the resultant of these two forces, is 8 newtons to the right. Then what would happen if on this force we include another force? This green force, it is also 8 newtons, but it is going to the left. So now, if we had to calculate the resultant of these two forces, the resultant is no longer going to be 8 because now we have 3 forces, so the resultant is no longer going to be 8. Our resultant now will change to be, we'll say 18 plus negative 8 plus negative 10. Our resultant is going to be 0 newtons. And again, these 3 forces, now the object has been is being put in a state of balance. So because of this 8, the object is now balanced, the object is now in a state of equilibrium. This force that we brought about, if you remember, our first resultant was 8 newtons to the right. Then we brought in this 8. This 8 is the one that causes it to balance. Now when you look at this 8, it is 8 newtons, but it's going way to the left. Our resultant without this 8, our resultant is 8 newtons going to the right. But when we bring in this 8 newtons, the one in green, this 8 newtons is exactly opposite to the direction of the resultant. This 8 will be known, or this force that is causing equilibrium will be known as equilibrant. Equilibrant, okay? So equilibrant is basically a force that brings about equilibrium. That is why even the name is derived from equilibrium. Equilibrant is a force. This one is a force, and it brings about equilibrium. Equilibrium is a force that is equal to the resultant but acts in the opposite direction. Okay, so that is how you can define the equilibrant. The equilibrant is a force equal in magnitude to the resultant but acting in the opposite direction. Or you can say equilibrant is a force that is equal in size to the resultant but acting in the exact opposite direction. It is a force that brings about balance. That is what we'll be looking at. So with these three in mind, they will ask us for any of them for us to define any of them, but that will be most of the definitions that we'll find. With these few examples that we've been looking at, we have our 18 newtons, we have our 10 newtons. These forces can either be acting on an object parallel to the horizontal, or they can be acting on an object whichever direction. What we have is that these examples that we've been looking at, these kind of forces are called direct forces. These are forces, for example, if we take this 18, all of this 18 is acting perpendicular to the object. This 18 in this other example is also acting, all of this 18 goes into the object, all of this 10 is going into the object. So this type of forces are known as direct forces, or the force is acting onto the object. It's a direct force. That is how you'll be resolving. Typical questions will be like this ones. They ask you, determine the equilibrant of these two forces, or find the resultant of these two forces. With the equilibrant, there is no special case of solving for the equilibrant. What you need to do is first solve for the resultant. After you solve for the resultant, then you opposite the direction of the resultant. Once you find the resultant and you opposite the direction of the resultant, what we get is the equilibrant. In this case, we got 8 newtons to the right. The opposite of right is left. When we opposite the 8 newtons and we say left, it becomes the equilibrant. It is the force that will balance out these two forces. If we add 8 newtons to the left onto this object, then it will be balanced. So 8 newtons to the left, that's the equilibrant of these two forces. Okay, direct forces. The other set of forces that you come across are known as oblique forces. Oblique forces are forces that are acting on an object at a certain angle. So like we said, a force will always have a direction. If it is a diagram, they will show it by an arrow. So I'm showing this. So let's say this force is acting at an angle. This is our force of 100 newtons. This force of 100 newtons is an oblique force that is acting at an angle other than 90 degrees. It is not acting directly on this force. It is not pushing it to the left only, but it is also pushing this force downwards. So when we look at this force, the 100 newtons, this 100 newtons is pushing this force slightly to the left, and at the same time it is pushing this object slightly downwards. It is acting into two directions at the same time, and that is what an oblique force is. An oblique force is a force that is acting at an angle other than 90 degrees to the object. Oblique forces will always have two components, the horizontal component and the vertical component. Okay, so every time we come across an oblique force, we should be able to resolve it into these two components, the horizontal component and the vertical component. The easiest way, every time we get an oblique force, the easiest way is for us to reduce this force into a triangle. let's say for example that force, the 100, we'll say our 100 is our hypotenuse, and we create such an angle 90 degrees there. Our angle that is given 30 degrees as that. The horizontal component will be this side. The vertical component will be what we have in that direction. So if we take our arrow on that side, this horizontal component is also going in that direction. That is the force pushing to the left. The vertical component is the force that is pushing downwards. So every time we have an oblique force, let's reduce it to a triangle. And with a triangle, it becomes much easier. We can use all the trig ratios, the tan, the cos, and the sine will apply on this. Then we can also even use the Pythagoras theorem on the triangle, a right angle triangle. Every time we get an oblique force, let's reduce it to a triangle and it becomes much easier. So in this case, if we are looking for the horizontal component, what we will use is that we have our hypotenuse, which is the longest side. We are looking for the adjacent. The ratio that we will use to get the horizontal component will be cos, because we know cos theta is equals to the adjacent. In this case, that is our horizontal component over our hypotenuse. So cos 30 is equals to your horizontal component over your hypotenuse 100. We cross multiply that. Horizontal component is equals to 100 cos 30, which will gives us 86,603 newtons. If our question is in newtons, then we resolve it as newtons. Now, every time we are using the trig ratios, cos, sine, or tan, make sure your calculator is in degrees, or else you'll be getting different answers. So just make sure that your calculator is in degrees. Okay, so we have resolved the horizontal component. Our 86,603 newtons is pushing in that direction, and how much is pushing downwards as a result of that force? We'll use our sine ratio. Sine theta is equals to our opposite. In this case, is our vertical component over our hypotenuse. Sine 30 is equals to vertical component over 100. We cross multiply. Vertical component will be 100 sine 30, 50 newtons. 50 newtons. Now, like we said, these are now vectors. Like we have said, this 86,603 is pushing to the left. The 50 newtons is pushing downwards. That is how you'll be resolving oblique forces, forces that are at an angle. Alright, here's now a question for the N2. The question reads as follows. The horizontal component of a force that forms an angle of 28 degrees if the horizontal is 520 kilonewtons. Determine the vertical component of the force. Okay, this is just a typical question that you might come across. So with such a question, what you really need to pay attention to is understanding the question. And how do you understand the question is by making a sketch of what is being spoken of. So you really pay attention to what they are saying. So this force they are describing, this 520 newtons that has been spoken about, and this 520 newtons forms an angle of 28 degrees. So if we read the question, it says the horizontal component. So this 520 is the horizontal component of a certain force. The force, we do not even know the size of that force. And they say this force that they're talking about, it forms an angle of 28 degrees with the horizontal. The horizontal plane, if we have a horizontal plane, this force, let's say that force is going in that direction. This is our horizontal plane, and our angle is, our 520 will be in that plane. It is the horizontal component. It is not the actual force. We are not even concerned about what force is, but it is important that we state this 520 as the horizontal component of that force. If the force was, let's say, going in the downwards direction, let's say if it was going in that direction, our angle with the horizontal will still be 28. the horizontal component will still be 520 kilonewtons. Alright, so it doesn't matter which direction you take, but as long as you state that the force that has been spoken according to the question, that has been spoken of, that 520 is on the horizontal component. The force itself is not a concern for us. So now the question is asking, determine the vertical component. So this force, the unknown force, the one that I'm putting on question marks, the unknown force has got a vertical component because it is an oblique force. It forms an angle other than 90 degrees. So it has got a force that is pulling this force upwards. This is the vertical component, and that is what they are asking us for. So if we look at this angle, this is our angle 28 degrees, this is the horizontal component. What we are looking for is the vertical component, and in this case the ratio that we apply is we have the adjacent, we are looking for the opposite. We apply the tan ratio. Tan theta is equals to your vertical component over your horizontal component, opposite over adjacent. This is our adjacent there. So we say tan 28 is equals to our vertical component, that is what we are looking for, over our 520. We cross multiply, vertical component is equals to 520 tan 28 degrees, and what we have is 2764,489 kilonewtons. Okay, so that is how you resolve. The issue is just us understanding the question. What is the question asking us for? What is the question saying? In most cases they will hide the question inside the statement, but try to make a sketch before you start answering. Make a sketch of what you have understood. If you do not understand the question, then we'll be solving for something wrong. Even our sketch will not represent what has been described. Okay, so what if maybe they had asked, how much is this force? How much of this force, or what is the force itself? What is the magnitude of this force that you are talking about? Then we'll still use the trig ratios. But the trig ratio that we'll use in this case, we'll still use our horizontal component. We have our angle, we have our hypotenuse. So we'll use our cos theta is equals to your adjacent over your hypotenuse. Our hypotenuse is the force that we are looking for. Our 520 is our adjacent. Our 28 is our angle that we have. So we say cos 28 is equals to 520 over our hypotenuse, the force itself. So our hypotenuse is equals to 520 over cos 28, and this gives us 588.936 kilonewtons. Okay, so that is how you resolve these forces. However, this question that we had, it was only asking for this part. I just gave in this calculation as well. The next question reads as follows: the vertical component of a force P acting at 30 degrees to the horizontal is 100 newtons. Determine the value of the force P. So the vertical component of a force, this is our vertical component, we have our horizontal component. This force forms an angle of 30 degrees, and the vertical component of that force is 100. The vertical component of the force is 100 newtons. Then they're asking us determine the magnitude of that force. Whether you choose to draw the force, as long as you know your planes, this force is going in that direction. It forms an angle 30 degrees. The vertical component, which will be this part, will still be 100 degrees. And how much is that force? So whichever sketch you make, as long as the angle is between the horizontal plane and the force itself, and the vertical component is 100, then your sketch will still, your triangle will still give you the correct answer. So this is what we have. We are looking for the hypotenuse. We have the opposite to the angle. The trig ratio that we'll use is sine. It's opposite over our hypotenuse. Our hypotenuse is what we are looking for. Sine 30 is equals to 100 over our hypotenuse. We cross multiply. And we get 200. Alright, so this is how you resolve the forces, oblique forces.